Hey dear friend, you've found a quiet place to rest and dream. Tonight we'll journey into the gentle mysteries of the night sky, where every star holds a story and every shadow carries peace. Before we begin, I want you to know that you don't need to do anything right now. You don't need to solve problems or finish tasks. You don't need to stay awake. All you need to do is rest. Let your body sink deeper into comfort. Let your shoulders drop. Let your jaw relax. The world outside can wait. This moment belongs only to you and the quiet darkness above. Take a slow breath in, hold it gently, and let it go. The night sky has been waiting for you. It's been there every evening, patient and unchanging, a canvas of light stretched across the darkness. And tonight, we're going to explore it together, not with urgency or effort, but with the soft curiosity of someone drifting between waking and dreaming. Let's begin where we always begin, with what we can see when we simply look up. On a perfectly dark night far from city lights, your eyes can perceive about 6,000 stars, 6,000 points of light, each one a sun, each one burning across distances so vast that the mind can barely hold them. But you don't need to hold them. You can simply let them be there, twinkling softly like lanterns hung in an endless garden. The twinkling itself is not the stars changing. It's our atmosphere, that protective blanket of air wrapped around Earth, gently bending and shifting the light as it passes through. The stars themselves burn steady and constant. It's only our view that wavers, creating that gentle shimmer, that peaceful flicker that has captivated human eyes for hundreds of thousands of years. When you look at a star, you're not seeing it as it is now. You're seeing it as it was. Light travels fast, faster than anything else in the universe. And yet the distances are so enormous that even light takes time. The nearest star to us, aside from our own sun, is Proxima Centauri, and its light takes just over 4 years to reach your eyes. You're looking 4 years into the past every time you see it. Most of the stars you see are much farther, dozens of light years away, hundreds. When you gaze at the night sky, you're looking at a museum of time, a gallery where every exhibit comes from a different moment in history. Some of the light reaching your eyes tonight left its star before you were born, some before your grandparents were born. And in this way, the night sky is a gentle reminder that time moves in strange and beautiful ways. The past is still arriving. The present is always unfolding. And the future is already on its way, traveling toward us in beams of light we haven't yet seen. There's a constellation that many people recognize, even if they don't know the names of others. Orion, the hunter, with his belt of 3 bright stars lined up in a row. Those 3 stars, Alnitak, Alnilam, and Mintaka, are not close to each other in space. They only appear that way from our perspective here on Earth. One is about 800 light years away. Another is over 1,000. They're separated by hundreds of light years, and yet to us they form a perfect line, a kind of cosmic coincidence that makes the sky feel like it was arranged just for us. Orion's shoulder, the bright reddish star called Betelgeuse, is a supergiant, a star so large that if you placed it where our sun is, it would swallow Mercury, Venus, Earth, and Mars. Its surface would reach nearly to the orbit of Jupiter, and yet from here, it's just a gentle red dot, pulsing softly in the winter sky. Betelgeuse is old. It's nearing the end of its life. Someday, perhaps soon in cosmic terms, it will explode in a supernova, a burst of light so brilliant that it might be visible during the day for weeks. But that someday could be tomorrow, or it could be 100,000 years from now. The universe doesn't hurry. It moves on timescales that make human lifetimes feel like single breaths. And when Betelgeuse does explode, the light from that explosion will travel across space for more than 600 years before it reaches Earth. So even that dramatic ending will arrive gently, patiently, in its own time. There's comfort in that. The universe is never rushed. Stars burn for millions or billions of years. Light crosses the void at its own steady pace. Galaxies turn like slow wheels. Everything unfolds in its own rhythm, and there's no urgency, no deadline, no pressure, just existence unfolding moment by moment. Let that thought settle over you like a blanket. You too can move at your own pace. You too are part of this slow and patient unfolding. The Milky Way, our home galaxy, is a river of stars stretching across the sky. On a truly dark night, you can see it as a pale band of light, a soft glow tracing a path from one horizon to the other. The ancient Greeks thought it looked like spilled milk, and so they named it the Milky Way. Other cultures saw a river, a road, a bridge between worlds. What you're seeing is the combined light of billions of stars, so many that they blend together into a luminous haze. You're looking at the edge of the galaxy, seeing it from the inside, from our position about 2/3 of the way out from the center. We live in one of the spiral arms, a quiet neighborhood far from the crowded, chaotic core. And that core, the heart of the Milky Way, is home to a supermassive black hole. It sits there silent and invisible, pulling everything around it into a slow orbit. The black hole itself is called Sagittarius A star, and it weighs about 4 million times as much as the Sun, and yet it's quiet. It doesn't rage or roar. It simply exists, a point of profound gravity around which hundreds of billions of stars slowly dance. Black holes are often imagined as terrifying, destructive forces, but in truth, they're gentle in their own way. They don't reach out and grab things. They simply curve space so deeply that anything passing too close falls in. From a distance, they're no more dangerous than any other massive object. A black hole with the mass of the Sun would pull on you exactly as much as the Sun does. It's only up close, near the edge of the event horizon, that things become strange and final. But out here, where we live, black holes are just another feature of the cosmos, quiet and patient, waiting in the dark. There are more stars in the universe than grains of sand on all the beaches on Earth. This is one of those facts that gets repeated often, and yet it remains astonishing every time you consider it. Billions of stars in our galaxy, hundreds of billions of galaxies in the observable universe, each one a sun, each one potentially surrounded by planets, moons, clouds of dust and gas, and most of them we will never see. They're too far away, too faint, hidden behind curtains of cosmic distance. But they're there, burning quietly, living out their long lives in corners of space we'll never visit, never even glimpse with our most powerful telescopes. There's something peaceful about that. The universe doesn't need us to see it. It doesn't need witnesses or applause. It simply is, vast and indifferent and beautiful whether we look at it or not. When you see a shooting star, you're not actually seeing a star. You're seeing a tiny piece of dust or rock, often no bigger than a grain of sand, burning up in Earth's atmosphere as it falls. The friction with the air heats it to thousands of degrees, and for just a moment, it glows bright enough to catch your eye. These meteors are often fragments left behind by comets. As a comet passes near the Sun, it sheds material, leaving a trail of debris along its orbit. When Earth passes through that trail, we get a meteor shower, dozens or even hundreds of these tiny travelers burning up in a beautiful cascade. The Perseid meteor shower happens every August, the Geminids in December, the Leonids in November, each one a reliable, returning gift from the universe, a reminder that we're moving through space, constantly crossing paths with ancient trails left by wanderers from the outer solar system. And when you see one, that brief streak of light, you're witnessing the end of a journey that might have begun thousands or even millions of years ago. That tiny piece of rock or ice has been drifting through the solar system, alone and silent, until finally, it meets Earth's atmosphere and goes out in a brilliant flash. There's poetry in that. Even the smallest things have their moment to shine. The moon is the brightest object in our night sky, and yet it produces no light of its own. Everything you see is reflected sunlight, bouncing off gray rock and ancient dust, traveling back to your eyes. The moon is a mirror, showing you the sun even after the sun is set. The surface of the moon is covered in craters, scars from billions of years of impacts. Early in the solar system's history, there was far more debris floating around, chunks of rock and ice left over from the formation of the planets. The moon, with no atmosphere to burn them up, took hit after hit, each impact leaving a permanent mark. The largest of these craters are called Maria, Latin for seas, because early astronomers thought they looked like bodies of water. They're not, of course. They're plains of solidified lava, dark and smooth, formed when ancient impacts cracked the moon's crust and allowed molten rock to flow up and fill the basins. The moon has been geologically dead for billions of years. No volcanoes, no earthquakes, no shifting plates, just stillness, silence, and the slow accumulation of dust as micrometeorites continue to rain down, grain by grain. And yet it's not lonely up there. 12 humans have walked on the moon. They left footprints in the dust, footprints that will last for millions of years because there's no wind or water to erase them. They left flags, scientific instruments, plaques, even a few golf balls. The moon holds these small human artifacts like treasures, quiet reminders that we reached out just for a moment and touched something beyond our world. The phases of the moon are caused by its position relative to the sun and Earth. When the moon is between Earth and the sun, we see the side that's in shadow. That's a new moon invisible in the sky. As the moon moves in its orbit, more of the sunlit side becomes visible. A crescent, then a half, then a gibbous, and finally a full moon, when the entire face is illuminated. Then the cycle reverses. The light retreats, night by night, until once again the moon disappears into darkness, and the cycle begins anew. This rhythm has governed human life for millennia. Ancient calendars were based on the moon's phases. Farmers planted and harvested by them. Tides rise and fall with them, pulled by the moon's gravity as it orbits overhead. Even now, in our modern world of electric lights and digital clocks, the moon still affects us in subtle ways. Animals time their activities by it. Corals spawn according to lunar cycles. Some people report changes in sleep patterns around the full moon, though scientists debate whether this is real or imagined. Perhaps it doesn't matter. The moon is there, cycling through its phases, a constant and reliable presence in an ever-changing world. If you could somehow stand on the surface of the sun, which of course you couldn't because it's a ball of superheated plasma with no solid surface, but if you could, you'd weigh about 28 times what you weigh on Earth. The sun's gravity is immense, powerful enough to hold 8 planets, hundreds of moons, and countless asteroids and comets in orbit. And yet the sun is not particularly large as stars go. It's actually quite average. There are stars 1,000 times larger. Stars so massive that they burn through their fuel in just a few million years and explode in spectacular supernovas. Our sun, by contrast, is calm and steady. It's been burning for about 4.5 billion years, and it has another 5 billion years to go before it exhausts its hydrogen fuel and begins to change. When that happens, the sun will swell into a red giant, growing so large that it will likely swallow Mercury and Venus, and possibly Earth as well. But that's so far in the future that it's almost meaningless. 5 billion years from now, the Earth will be unrecognizable anyway, shaped by eons of evolution, continental drift, and perhaps by civilizations we can't even imagine. For now, the sun rises and sets, reliable and warm, giving us light and life, day after day after day. Sunlight takes about 8 minutes to travel from the sun to Earth. This means that when you look at the sun, you're seeing it as it was 8 minutes ago. If the sun suddenly vanished, we wouldn't know for 8 minutes. We'd keep seeing it, keep feeling its warmth, and then, all at once, it would blink out and the world would go dark. Of course, the sun won't suddenly vanish. Stars don't do that. They burn steadily, predictably, governed by the laws of physics that apply everywhere in the universe. But there's something strange and beautiful about that 8-minute delay. It's a reminder that distance and time are connected, that everything we see is a little bit in the past, and that the present is always just out of reach. The Big Dipper is not actually a constellation. It's an asterism, a recognizable pattern that's part of a larger constellation called Ursa Major, the Great Bear. The Big Dipper's 7 bright stars form the bear's hindquarters and tail. These stars have names: Dubhe, Merak, Thecta, Megrez, Alioth, Mizar, and Alkaid. They're written in the sky like a cosmic recipe, a set of ingredients that cultures around the world have used to navigate, tell time, and mark the seasons. If you follow the 2 stars at the end of the Dipper's bowl, Dubhe and Merak, and extend a line upward, you'll find Polaris, the North Star. Polaris sits almost directly above Earth's North Pole, which means it barely moves as the sky rotates around it. For centuries, sailors have used it to navigate, always knowing that Polaris marks true north. The North Star isn't the brightest star in the sky. It's not even in the top 40, but it's bright enough, and more importantly, it's in the right place, a steady beacon in a turning sky. Polaris won't always be the North Star. Earth's axis wobbles very slowly, taking about 26,000 years to complete one cycle. This wobble, called precession, means that the North Pole gradually points at different stars. 5,000 years ago, the pole star was Thuban, in the constellation Draco. In about 12,000 years, it will be Vega, one of the brightest stars in the sky. Everything shifts, everything changes, but so slowly that a human lifetime sees only the tiniest movement. The sky you see is nearly the same sky your great-great-grandparents saw, and nearly the same sky your great-great-grandchildren will see. There's a galaxy called Andromeda, visible to the naked eye on a dark night as a faint, fuzzy patch of light. It's the most distant thing you can see without a telescope, sitting about 2.5 million light-years away. Andromeda is similar to the Milky Way, a spiral galaxy containing hundreds of billions of stars, and it's moving toward us. Not quickly, but inexorably, pulled by gravity across the void. In about 4 billion years, Andromeda and the Milky Way will collide. When galaxies collide, they don't crash like solid objects. They're mostly empty space, after all. The stars are so far apart that almost none of them will actually hit each other. Instead, the galaxies will pass through each other, their shapes distorting, their stars being pulled into new orbits by the changing gravitational landscape. Eventually, after several passes, the 2 galaxies will merge into a single, larger galaxy, a giant elliptical cloud of stars that astronomers have already nicknamed Milkomeda. But this collision will unfold over hundreds of millions of years. It will be slow, graceful, like a dance, and by the time it happens, Earth will either be long gone, swallowed by the dying sun, or transformed beyond recognition by time and evolution. The universe operates on timescales so vast that even cataclysmic events unfold gently, without hurry. There are planets made of diamond, or at least planets where the intense pressure and heat have compressed carbon into crystalline structures. These are thought to exist around certain types of stars, where the conditions are just right to turn carbon-rich material into something glittering and hard. There are planets where it rains glass sideways in howling winds that reach thousands of miles per hour. There are planets so hot that metal vaporizes into clouds. There are planets so cold that the atmosphere itself freezes and falls as snow. There are planets orbiting 2 stars, where the sunsets come in pairs, one sun dipping below the horizon followed by another. There are rogue planets, untethered to any star, wandering through interstellar space alone, and dark, and frozen. The variety is staggering. The universe is not content to make one kind of world. It experiments endlessly, creating every possible variation, testing the limits of what matter and energy can do. And among all these strange and exotic worlds, Earth is strange and exotic too. A planet with liquid water covering most of its surface. A planet with an atmosphere that's transparent to visible light. A planet where life has not only emerged but flourished, filling every available niche with an astonishing diversity of forms. We live on a rare jewel, spinning quietly in the darkness, and the night sky above us is a reminder of both how special this place is and how much more is out there waiting. Light pollution has hidden the stars from most of humanity. If you live in or near a city, you might see a few dozen stars on a clear night, maybe 100 if you're lucky. The rest are washed out by streetlights, billboards, buildings, the collective glow of human civilization. But the stars are still there. You just can't see them. If you travel far from cities, to mountains or deserts or open plains, the sky opens up. Thousands of stars appear. The Milky Way reveals itself. The universe comes into focus. There's a map that shows Earth at night, lit up by human lights, and it's beautiful in its own way. You can see the coastlines traced in glowing cities, the rivers marked by chains of towns, the great megacities blazing like fallen stars. But there's also a cost. We've traded the night sky for electric light. We've made ourselves safer and more productive, but we've lost something ancient and essential. The darkness that our ancestors knew. The deep, star-filled darkness that shaped human imagination for thousands of generations. Some places are fighting to bring it back. Dark sky preserves where lighting is carefully controlled to minimize glare and spillover. Communities adopting shielded streetlights that point down instead of up. Small efforts, but meaningful, trying to restore a little bit of what was lost. Because the night sky is not just a collection of scientific facts. It's a source of wonder, a reminder of scale and mystery, a doorway to questions that have no easy answers. Who are we? Where did we come from? Are we alone? The night sky holds these questions softly, without demanding answers, and invites us to simply wonder. There's a phenomenon called earthshine, where the dark part of the moon glows faintly with light reflected from Earth. When the moon is a thin crescent, you can sometimes see the rest of its disk faintly illuminated, a ghostly circle holding the bright crescent like a cup. This is Earth's light, bouncing off our planet's clouds and oceans, traveling to the moon and back. The moon shows us ourselves, reflected in its ancient surface. Leonardo da Vinci was the first to correctly explain earthshine, understanding that it was Earth's reflected light, rather than some intrinsic glow of the moon itself. He wrote about it in his notebooks, sketching the phenomenon and pondering what it meant. Even genius, even 500 years ago, looked at the night sky and wondered. There are objects in the sky that don't move with the stars. They're called planets from the Greek word for wanderer. To the ancients, these wanderers were mysterious and important, gods written in light, moving against the fixed backdrop of the heavens. Mercury, Venus, Mars, Jupiter, and Saturn are all visible to the naked eye, and they've been known since prehistoric times. They move slowly across the sky, following a path called the ecliptic, the plane in which all the planets orbit the sun. Each planet has its own rhythm. Mercury is fast, zipping around the sun every 88 days, rarely straying far from the sun in the sky. Venus is slow and stately, the brightest object in the sky after the sun and moon, visible as the morning star or evening star. Mars is red, colored by iron oxide, rust on a planetary scale. Jupiter is a giant, the largest planet striped with clouds and crowned with a storm larger than Earth that's been raging for centuries. Saturn, even with the naked eye, has a slightly elongated shape, a hint of the magnificent rings that surround it. Uranus and Neptune are too faint to see without a telescope, and Pluto, now classified as a dwarf planet, is far too small and distant. But the 5 classical planets have watched over humanity since the beginning, silent wanderers tracing their endless loops across the sky. The sun doesn't actually rise or set. Earth rotates, turning you toward the sun or away from it, creating the illusion of movement. The sun sits still, at least relative to us, and we spin like a child's top, once every 24 hours. This rotation creates day and night, light and darkness, a rhythm that life on Earth has adapted to so completely that it's written into our biology. Circadian rhythms, internal clocks that tell plants when to open their flowers and animals when to sleep and wake. Your own body knows this rhythm. Even in a windowless room, even without any external cues, your body would settle into a roughly 24-hour cycle, though it might drift a bit, becoming slightly longer or shorter. You're built for this rotation, for this dance of day and night. Your body expects it, craves it, needs it to function properly. So as you rest now, as the day falls away and night settles in, know that this is natural. This is right. Your body is doing exactly what it's meant to do, responding to the ancient rhythm of a spinning planet. Comets are dirty snowballs, chunks of ice and rock and dust, leftovers from the formation of the solar system, orbiting in the cold outer reaches or even beyond. When a comet's orbit brings it close to the sun, the ice begins to vaporize, creating a glowing cloud called a coma, and often a tail that streams away from the sun, blown by the solar wind. Comets have been seen as omens throughout history. The sudden appearance of a bright-tailed visitor in the sky inspired fear, wonder, superstition. Some cultures saw them as warnings, others as signs of coming change. Halley's Comet is the most famous, returning every 75 to 76 years. It was recorded by ancient astronomers in China, Babylon, and Greece. It appeared in 1066, and the Normans took it as a sign that they would conquer England, which they did. It appeared in 1910, when people panicked because astronomers had discovered that Earth would pass through the comet's tail, and some worried that toxic gases would poison the atmosphere. Nothing happened, of course. The tail is so diffuse that it's essentially a vacuum. Halley's Comet last appeared in 1986, and it will return in 2061. If you're young enough, you might see it twice in your lifetime, once as a child and once in your old age, a visitor that connects your beginning and your end. There's something humbling about that. Comets outlast us. They were here long before us, and they'll continue their slow orbits long after we're gone. Space is not completely empty. Even in the vast distances between stars, there's something. Hydrogen atoms, 1 or 2 per cubic centimeter, tiny grains of dust, molecules of water, carbon monoxide, even amino acids, the building blocks of life. This thin haze is called the interstellar medium, and it's where new stars are born. In the densest regions called molecular clouds, the gas and dust collapse under their own gravity, heating up, spinning faster, until fusion ignites and a star is born. These stellar nurseries are enormous, light years across, containing enough material to make thousands or even millions of stars, and they're beautiful. When viewed through telescopes, they glow with the light of newborn stars, intricate structures of gas and dust shaped by radiation and magnetic fields. The Eagle Nebula, the Orion Nebula, the Carina Nebula, cathedrals of creation, where the universe is still making new light. And every atom in your body came from a place like this, not these specific nebulae, but ancient clouds that collapsed and formed stars billions of years ago. Those stars lived and died, some exploding in supernovas, scattering their material back into space. That material eventually became part of a new cloud, which collapsed again, forming our sun and the planets, including Earth. You are made of stardust. This is not a metaphor. It's literal truth. The calcium in your bones, the iron in your blood, The oxygen you breathe, all of it was forged in the nuclear furnaces of dying stars. You're not separate from the universe. You're part of it, a way for the cosmos to know itself, to look back at its own history and wonder. The speed of light is fast, but the universe is vast, and so light takes time to travel. Light from the moon takes about 1 second to reach Earth. Light from the sun takes 8 minutes. Light from Neptune takes about 4 hours. Light from the nearest star takes 4 years. Light from the center of our galaxy takes 26,000 years. Light from Andromeda takes 2.5 million years. When you look at very distant galaxies through a telescope, you're seeing them as they were billions of years ago, when the universe was young. You're looking back in time, watching the past unfold. The most distant galaxies we've detected formed when the universe was less than 1 billion years old, just a small fraction of its current age of nearly 14 billion years. These galaxies are so far away that their light has been traveling toward us for over 13 billion years. And we're seeing them now, tonight, as they were then, frozen in time by the speed of light and the vastness of space. There's no way to see these galaxies as they are now. Now is meaningless at such distances. By the time their current light reaches us, billions more years will have passed, and those galaxies will have changed beyond recognition. The universe is not a place. It's a place and a time, inseparably woven together, and distance equals delay. The farther you look, the further back you see. This is why astronomers can study the history of the cosmos. They don't need a time machine. They just need a telescope. There's a sound that space probes have recorded, though sound doesn't actually travel through the vacuum of space. These are electromagnetic waves, converted into audio frequencies so humans can hear them. The sounds are eerie, beautiful, haunting. Whistles and clicks and low rumbles. Jupiter makes sounds. Saturn makes sounds. Earth makes sounds. Our planet singing in frequencies we can't hear naturally, created by charged particles interacting with the magnetic field. These sounds have no practical purpose. They're just data, translated into a form we can experience. But they're moving anyway. These voices of worlds that have no atmospheres, no life, no ears to hear themselves. The universe is full of signals we can't perceive directly. Radio waves, X-rays, gamma rays, infrared and ultraviolet light. Our eyes see only a narrow slice of the electromagnetic spectrum, the range we call visible light. But just because we can't see something doesn't mean it's not there. The universe is richer, stranger, more complex than our senses reveal. We've built instruments to extend our senses, telescopes that see in infrared, revealing heat, detectors that pick up X-rays and gamma rays, showing us violent energetic events, radio dishes that listen to the cosmos, hearing the whispers of pulsars and the echoes of the Big Bang. Each new way of looking reveals something unexpected. The universe is never quite what we think it is. It's always more. Shooting stars aren't stars at all, but they're still magical. When you see one, tradition says you're supposed to make a wish. There's no logic to it, no reason it should work, and yet people have been wishing on shooting stars for as long as there have been people and shooting stars. Maybe it's because they're fleeting, a flash of light, brief and unrepeatable, something that happens and then is gone forever, like a moment of grace, a small gift from the universe. Or maybe it's just that we want to feel connected to something larger, and a shooting star gives us an excuse to pause, to wonder, to hope. Whatever the reason, if you see a shooting star tonight, even in your mind as you drift toward sleep, make a wish. Not because it will come true, but because wishing is a form of hope, and hope is always worth having. The aurora borealis, the northern lights, and their southern counterpart, the aurora australis, are caused by charged particles from the sun colliding with Earth's atmosphere. These particles are funneled toward the poles by Earth's magnetic field, and when they hit atoms of oxygen and nitrogen in the upper atmosphere, They cause those atoms to glow. Oxygen glows green and red. Nitrogen glows blue and purple. The result is a shimmering curtain of color dancing across the polar sky. One of the most beautiful natural phenomena on Earth. The auroras are more than beautiful. They're a visible reminder that Earth is connected to the sun, that we live inside our star's sphere of influence, bathed in its light and touched by its wind. Solar wind is a stream of charged particles flowing outward from the sun in all directions. It's thin, far thinner than any vacuum we can create on Earth, but it's there, filling the solar system, pushing against the magnetic fields of planets, sculpting the tails of comets. When the solar wind is particularly strong, usually after a solar flare or coronal mass ejection, the auroras intensify and spread. They can be seen farther from the poles, reaching down into latitudes where they're normally absent. People in northern Canada, Alaska, Scandinavia, and Siberia grow up with the auroras. They're part of life, expected, almost ordinary. But for people who rarely see them, the experience is unforgettable. The sky itself seems alive, glowing and shifting, colors you didn't know the sky could make. It's a reminder that we live on a planet, a world among worlds, floating in space, protected by invisible fields and thin layers of gas. We're vulnerable and small, and yet we're here, alive, watching the sky dance. The stars you see are not evenly distributed. They're arranged in patterns we call constellations, though these patterns are artificial, created by human imagination, rather than any real connection between the stars. Different cultures see different patterns. The Greeks saw heroes and monsters, gods and animals. The Chinese saw a celestial bureaucracy, officials and palaces mirroring their earthly empire. Indigenous Australians saw ancestors and stories of creation. The constellations we use today are based mostly on Greek and Roman mythology, standardized by astronomers over the past few centuries. There are 88 official constellations, covering the entire sky, each with defined boundaries. But the stars themselves don't know they're in constellations. They don't know they're part of Orion or Ursa Major or Scorpius. They're just stars, doing what stars do, burning hydrogen, shining light into the void. The patterns are ours. The meanings are ours. The stories are ours. And that's part of the beauty. The universe doesn't come with labels or explanations. We create those, weaving narratives and finding connections, making sense of the chaos. The sky is a canvas, and we're the painters. There's a star called Sirius, the brightest star in the night sky, part of the constellation Canis Major, the Great Dog. Sirius is about twice as massive as the sun and much hotter, burning with a brilliant blue-white light. It's only about 8.5 light-years away, relatively close by cosmic standards, which is part of why it's so bright. Its name means scorching or glowing, and in ancient Egypt, its appearance in the dawn sky signaled the annual flooding of the Nile, a crucial event that brought fertility to the land. Sirius has a companion, a tiny white dwarf star called Sirius B, orbiting it every 50 years. White dwarfs are the remnants of stars that have exhausted their fuel and collapsed to incredibly dense cores. A teaspoon of white dwarf material would weigh several tons on Earth. Sirius B is invisible to the naked eye, far too faint to see, but it's there, a silent partner, orbiting in a cosmic dance that's been going on for eons. Many stars are not alone. More than half of all stars exist in binary or multiple systems, 2 or more stars orbiting a common center of mass. Some of these systems are wide, with the stars separated by distances comparable to our solar system. Others are close, the stars nearly touching, exchanging material in a complex gravitational ballet. Our sun is unusual in being solitary. It has no stellar companion, just planets, small and cold and dark. There's speculation that the Sun might have had a companion long ago, early in its history. Another star formed from the same cloud of gas and dust. But if so, that companion was lost, ejected from the system, or stolen by a passing star, leaving the Sun alone. We'll never know for sure. The early history of the solar system is lost to time, erased by billions of years of chaos and change. But the Sun doesn't seem lonely. It has its planets. It has us. And it shines steadily, reliably, giving light and warmth day after day. There are clouds in space, but they're not like clouds on Earth. They're enormous structures of gas and dust, sometimes glowing, sometimes dark, stretching across light years of space. Dark nebulae are clouds that block background light, appearing as dark patches against the star-filled sky. The Coalsack Nebula is one of these, visible to the naked eye in the southern hemisphere, as a dark smudge against the Milky Way. Emission nebulae glow with their own light, energized by nearby stars. The hydrogen gas absorbs ultraviolet light from hot young stars and re-emits it as visible red light, creating clouds that glow like cosmic neon signs. Reflection nebulae are clouds of dust that reflect the light of nearby stars, glowing blue like Earth's sky does during the day. The blue color comes from the same process, tiny particles scattering shorter wavelengths of light more efficiently than longer ones. These nebulae are stellar graveyards and nurseries both. Old stars die and scatter their material into space. New stars form from that material, pulling it together, recycling it, creating new light from old matter. Nothing in the universe is wasted. Everything is reused, reformed, given new purpose. Death and birth are not opposites, but partners in an endless cycle. Your own body participates in this cycle. The atoms that make you up have been part of countless other things. They've been in rocks, in water, in plants, in other animals. They've been rearranged and recombined over and over, and someday they'll be something else. You are temporary, but you are also eternal. The matter that forms you has existed since shortly after the Big Bang, and it will continue to exist long after you're gone, taking new shapes, living new stories. There's comfort in that continuity. You're part of something larger than yourself, something ancient and ongoing. The zodiac constellations are the ones the Sun appears to pass through during the year as Earth orbits around it. Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpio, Sagittarius, Capricorn, Aquarius, and Pisces. These are the constellations that lie along the ecliptic, the plane of Earth's orbit. Ancient astronomers noticed that the planets also moved through these constellations, since all the planets orbit in roughly the same plane. This made the zodiac seem special, significant, and it became the basis for astrology, the belief that the positions of celestial bodies influence human affairs. Astronomy and astrology were once the same discipline. Ancient astronomers were also astrologers, studying the sky both to understand the cosmos and to predict the future. But over time, the two separated. Astronomy became a science based on observation, measurement, and physical laws. Astrology remained a belief system, largely unchanged from ancient times. Modern astronomy has no place for astrological influence. The gravitational pull of Jupiter on a newborn baby is far weaker than the gravitational pull of the doctor holding the baby. The positions of distant stars have no physical mechanism by which they could affect human personality or destiny. And yet, the zodiac remains culturally significant. People still know their astrological signs. They still read horoscopes, still find meaning in the ancient patterns. Perhaps that's okay. Science tells us how the universe works, but it doesn't always tell us what things mean. Meaning is something we create, individually and collectively. And if people find meaning in the zodiac, who's to say they're wrong? The sky belongs to everyone. Everyone gets to decide what they see in it. Neutron stars are among the strangest objects in the universe. They're the remnants of massive stars that exploded in supernovas, their cores collapsing under gravity until protons and electrons are crushed together into neutrons. A neutron star is about 20 kilometers across, roughly the size of a city, but it contains more mass than the Sun. The density is incomprehensible. A sugar cube-sized piece of neutron star material would weigh as much as all of humanity combined. The gravity at the surface of a neutron star is about 2 billion times stronger than Earth's gravity. If you somehow stood on a neutron star, you'd be instantly flattened into a layer less than an atom thick. Neutron stars spin rapidly, sometimes hundreds of times per second, their intense magnetic fields channeling radiation into beams that sweep through space like lighthouse beams. When one of these beams points at Earth, we detect regular pulses of radio waves, and we call the object a pulsar. The first pulsar was discovered in 1967 by Jocelyn Bell Burnell, then a graduate student. The pulses were so regular that for a brief time, astronomers considered the possibility that they might be artificial, signals from an alien civilization. They jokingly called the source LGM-1 for little green men, but it wasn't aliens. It was physics. Strange and wonderful physics showing us that the universe could create objects we'd never imagined. There are hundreds of known pulsars now, each one a spinning lighthouse in the cosmic sea, and they're some of the most precise clocks in the universe. Their rotation is so regular that astronomers use them for navigation, timing, and even tests of relativity. Gravity bends space and time. This is one of the central insights of Einstein's general relativity, and it's been confirmed by countless experiments and observations. Near a massive object, time runs slower. An astronaut orbiting Earth ages slightly faster than someone on the ground, because time passes more quickly farther from a massive object. Light bends when it passes near a massive object. We can see this during a total solar eclipse, when stars near the sun's edge appear slightly displaced from their true positions because their light is bent by the sun's gravity. And when light passes near something truly massive, like a galaxy or a black hole, the bending can be extreme. The massive object acts like a lens, focusing light from objects behind it, sometimes creating multiple distorted images. This is called gravitational lensing, and it's one of the most beautiful phenomena in astronomy. Sometimes a distant galaxy is lensed into a ring, a perfect circle of light called an Einstein ring. Sometimes it's stretched into arcs and streaks, multiple images of the same object arranged around the lensing mass. Gravitational lensing isn't just beautiful, it's useful. Astronomers use it to study distant galaxies that would otherwise be too faint to see. They use it to map the distribution of dark matter, which is invisible but reveals itself through its gravitational effects. The universe bends light like a funhouse mirror, but unlike a funhouse, every distortion tells us something true about the nature of space and time. When you look up at the night sky, you're looking through a window in time. You're seeing light that has traveled for years, centuries, millennia, eons. You're seeing the universe, not as it is, but as it was. And in a strange way, the universe is looking back at you, not with consciousness or awareness, but simply because you're here, a part of the cosmos that has become self-aware, able to perceive and ponder and wonder. You are the universe observing itself. Your eyes are the universe's eyes. Your thoughts are the universe thinking. This isn't mysticism, it's fact. You're made of matter and energy that has existed since the beginning. You're arranged in a particular way, a configuration that allows for awareness, for experience, for the strange and wonderful phenomenon of consciousness. And for this brief moment, in this particular corner of space and time, the universe knows that it exists. That's remarkable. That's precious. That's worth celebrating, even in the quiet stillness of approaching sleep. There are more planets than stars in the Milky Way. This is a recent discovery, made possible by telescopes that can detect the tiny dimming of a star's light as a planet passes in front of it. Thousands of exoplanets have been discovered, and there are likely hundreds of billions more. Almost every star has at least one planet, and many have multiple planets in complex systems. These planets come in every size and type imaginable. Hot Jupiters, gas giants orbiting closer to their stars than Mercury orbits the Sun. Super-Earths, rocky planets larger than Earth but smaller than Neptune. Ice giants, ocean worlds, lava worlds, planets with multiple suns, planets orbiting dead stars. And somewhere among those hundreds of billions of planets, there might be life. Statistically, it seems almost certain the universe is too big, too old, too full of possibilities for Earth to be the only place where life emerged. But we haven't found it yet. No signals, no artifacts, no visitors, just silence. The great cosmic silence that makes us wonder if we're truly alone or just haven't been looking long enough. Either possibility is astonishing. If we're alone, then we're incredibly special. The only place in the universe where matter has organized itself into living, thinking beings. If we're not alone, then somewhere out there, under different skies, other beings are looking up and wondering the same things we wonder. Perhaps someday we'll know. Perhaps in your lifetime or your children's lifetime, we'll detect a signal, a message, proof that we're not alone. Or perhaps we'll remain alone, or at least isolated, separated from any other life by distances too vast to cross, or timescales too long to coordinate. Either way, the question remains open, a mystery written in the stars. The night sky changes with the seasons. In winter, different constellations are visible than in summer, because Earth's orbit carries us to different positions around the sun, changing which direction is dark and which is light. In the northern hemisphere, winter brings Orion, Taurus, Gemini. Summer brings Scorpius, Sagittarius, Cygnus. Each season has its own sky, its own patterns, its own character. Ancient peoples marked time by these changes. They knew when to plant and when to harvest by which stars were visible at dawn or dusk. The sky was a calendar, reliable and accurate, telling them where they were in the endless cycle of the year. Even now, even with our clocks and calendars and smartphones, the sky can tell you the season if you know how to read it. The stars are still there, still following their ancient patterns, still marking time. The stars don't care whether we notice them or not. They shine regardless. But there's something satisfying about being able to look up and know where you are in time, to see the familiar patterns and feel connected to the rhythm of the year. Summer nights are short and warm, the sky not fully dark until late. Winter nights are long and cold, the sky dark for hours on end. Each has its own beauty, its own gifts. Right now, in this moment, the sky is what it is. Tomorrow it will have shifted slightly, imperceptibly. Next month it will be noticeably different. Next year nearly the same again. The cycle continues, endlessly repeating, and you're part of it. Turning with the earth, orbiting with the sun, moving through space and time. There's something deeply restful about cycles. They repeat, but they're never quite the same. Each day is unique, each night different, and yet the pattern persists, giving structure and rhythm to existence. Your body knows this rhythm. It expects day and night, waking and sleeping, activity and rest. When you fight against it, staying awake when you should sleep, forcing activity when you need rest, your body becomes stressed, confused. But when you align with the rhythm, when you let yourself rest when darkness comes, everything becomes easier. Your body relaxes, your mind quiets. Sleep comes naturally, effortlessly. Right now, as you rest, you're doing exactly what you're supposed to be doing. You're honoring the rhythm, accepting the cycle, letting yourself be carried by it. There's wisdom in that surrender. Not giving up, but letting go, trusting that the process will unfold as it should. The universe has been unfolding for nearly 14 billion years, and it doesn't need your help. It doesn't need you to stay vigilant, to remain alert, to keep things running. You can rest. You can sleep. The universe will still be here when you wake. Meteors, the ones we call shooting stars, hit Earth's atmosphere at incredible speeds, anywhere from 25,000 to 160,000 miles per hour. At those speeds, friction with the air heats them to thousands of degrees in a fraction of a second. Most meteors are tiny, no bigger than a pebble, and they burn up completely before reaching the ground. A few are larger, and fragments survive the descent, landing as meteorites. Meteorites are some of the oldest objects you can hold in your hand. Many of them are pieces of asteroids, rocks that have been drifting through space since the solar system formed 4.5 billion years ago. Holding a meteorite is like holding a piece of history, a fragment of the ancient past. Some meteorites come from the moon or Mars, blasted into space by ancient impacts and eventually falling to Earth. We've found dozens of Martian meteorites, and they're the only samples of Mars we have on Earth, at least until future missions bring back deliberately collected samples. Every day, Earth gains about 100 tons of material from space, most of it in the form of tiny particles, micrometeorites too small to see. They drift down through the atmosphere, settling gently onto the surface, mixing into the soil, becoming part of Earth. You breathe in ancient stardust. It's in the air, microscopic grains of cosmic material, and it settles in your lungs, becomes part of your body, connects you physically to the wider universe. Everything is connected. The boundaries between you and not you are not as clear as they seem. Atoms flow back and forth. You're not a closed system, but an open one, constantly exchanging material with your environment, with the Earth, with the cosmos. In this way, you're not separate from the night sky. You're continuous with it, part of the same whole, made of the same substance. Comets have been visiting the inner solar system for billions of years, and each time they do, they lose a little bit of themselves. The ice vaporizes, the dust blows away. Eventually, after enough passes, a comet becomes inactive, a dark rock depleted of volatile materials, indistinguishable from an asteroid. Some comets break apart entirely, splitting into fragments that spread out along the orbit. When Earth passes through such a debris field, we get a meteor shower, dozens or hundreds of shooting stars in a single night, all remnants of a single comet that no longer exists. Everything ends eventually. Stars run out of fuel, planets cool and go dormant, comets evaporate, galaxies merge, even black holes eventually decay, radiating away their mass in a process so slow it takes longer than the current age of the universe. But endings aren't really endings, they're transformations. The material doesn't disappear. It just takes a new form, becomes something else, continues existing in a different way. Your own ending, when it comes, will be like this. The atoms that make you up will be released, returned to the world, eventually incorporated into other things. Nothing of you will be lost. You'll just be redistributed, scattered, given new forms. This is how the universe works. Nothing is created or destroyed. Everything is just rearranged. And in the meantime, while you're here, arranged in this particular configuration, you get to experience existence. You get to see the night sky, feel the cool air, hear the quiet sounds of evening. You get to rest and dream and wake again, day after day, until you don't. And that's enough. That's more than enough. There are galaxies so far away that their light has been stretched by the expansion of the universe. As space itself expands, the wavelength of light traveling through it gets stretched too, shifting toward the red end of the spectrum. This is called redshift, and it's one of the key pieces of evidence that the universe is expanding. The farther away a galaxy is, the faster it's receding from us and the more redshifted its light becomes. The most distant galaxies are so redshifted that their visible light has been stretched into infrared, invisible to our eyes. We need special telescopes to see them, instruments that can detect infrared light and convert it into images we can understand. These distant galaxies are young, formed when the universe was still in its infancy. They're small, irregular, chaotic. Nothing like the grand spiral and elliptical galaxies we see nearby. They're still forming, still growing, still figuring out how to be galaxies. Watching them is like looking at baby pictures of the universe, seeing how things began, how the first stars formed and the first galaxies took shape. And those galaxies are still out there, though we're not seeing them as they are now. By now, they've had billions of years to evolve, to grow, to mature. They might be grand spirals now, or they might have merged with other galaxies, or they might have been torn apart by gravitational interactions. We'll never know. Their present light won't reach us for billions of years, and by then, everything will be different. The universe is a story being told, and we're reading it one page at a time, always a little bit behind, never quite catching up to the present. The darkest places on Earth are far from cities, far from roads, far from any human light. Deserts, mountains, remote islands. In these places, the night sky opens up, revealing layers of depth and detail invisible anywhere else. The Milky Way becomes a river of light, so bright it casts shadows. Individual nebulae and star clusters become visible to the naked eye. The sky fills with stars until there's almost more light than darkness, a dome of glowing points that takes your breath away. People who see a truly dark sky for the first time often report feeling overwhelmed, dizzy, even frightened. The scale is so vast, the number of stars so great, that it can be disorienting, but it can also be profoundly moving. There's a sense of perspective that comes from seeing the universe as it truly is, not filtered through light pollution, not reduced to a few dozen stars, but in its full, overwhelming glory. You realize how small you are, how brief your life is, how insignificant your worries and fears are against the backdrop of cosmic time and space. And paradoxically, this realization can be comforting. If you're small and brief, then your mistakes are small and brief too. Nothing you do wrong is permanent. Nothing you fail at matters in the grand scheme. You're free to be imperfect, to make mistakes, to fail, because none of it changes the fact that the universe is vast and beautiful and doesn't care about your performance review, or your social anxieties, or your embarrassing moments. You can just be. You can just exist. And that's enough. The solar system is moving, not just spinning in place, but traveling through space, orbiting the center of the Milky Way at about 500,000 miles per hour. At that speed, it takes about 200 million years to complete one orbit. The last time the solar system was in this part of the galaxy, dinosaurs were just beginning to emerge on Earth, and the Milky Way itself is moving, pulled by gravity toward a concentration of mass called the Great Attractor, and beyond that, toward an even larger structure called the Shapley Supercluster. Everything is moving. Nothing is still. The universe is a vast dance, everything pulling on everything else. Orbits within orbits. Motion everywhere, all the way down to the smallest scales and up to the largest. You're moving too, right now, even as you rest. You're spinning with the Earth, orbiting with the Sun, traveling with the galaxy, participating in the great cosmic dance. You can't feel it because everything around you is moving with you, but it's happening. You're in motion, hurtling through space at incredible speeds, and you're perfectly safe, held in place by gravity, protected by atmosphere, cradled by the Earth. There's nothing to fear in this motion. It's natural, universal, the way things are. Everything moves. Everything changes. And yet moment to moment, breath to breath, you're here, experiencing this now, this present instant. And that's all you ever have. Just this moment, and then the next one, and then the next. The past is gone, already receding into memory and history. The future hasn't arrived yet, still traveling toward you at the speed of time. All you have is now, this breath, this heartbeat, this moment of rest. And this moment is enough. White dwarfs are common in the universe. They're what most stars become when they die, including our sun. After exhausting their hydrogen fuel, stars like the sun swell into red giants, then shed their outer layers and collapse into white dwarfs, hot and dense and slowly cooling. A white dwarf has no internal energy source. It shines only with residual heat, gradually radiating that heat away into space. The cooling process takes billions of years longer than the current age of the universe, so every white dwarf we can see is still hot, still glowing. Eventually, trillions of years from now, white dwarfs will cool completely, becoming black dwarfs, cold and dark and dead. But that future is so distant that it's hard to even conceptualize. The universe is still young, relatively speaking. The era of black dwarfs hasn't begun. For now, white dwarfs glow faintly in the darkness, quiet monuments to stars that once burned bright. One day our sun will become a white dwarf. It will swell first, becoming a red giant, possibly swallowing the inner planets. Then it will shed its outer layers in a beautiful planetary nebula, a glowing shell of gas expanding into space. And at the center will be the sun's core, exposed and cooling, a white dwarf about the size of Earth, made mostly of carbon and oxygen, the ashes of nuclear fusion. This will happen in about 5 billion years, give or take a few 100 million. It's so far in the future that it's meaningless for us personally. Humanity will either be long extinct or evolved into something unrecognizable by then. But the sun will still be there, transformed but not gone, continuing to exist in a new form, patiently cooling through the eons. Infinity is a strange concept. The universe might be infinite, stretching on forever in all directions, filled with an infinite number of galaxies, stars, planets. Or it might be finite but unbounded, like the surface of a sphere. You can travel in any direction forever and never reach an edge, but the total area is still finite. We don't know which is true. The observable universe, the part we can see, is finite, limited by the speed of light and the age of the universe. Light from beyond a certain distance hasn't had time to reach us yet, so we can't see it. But beyond that horizon, there's more universe. Regions we'll never see because the expansion of space carries them away faster than light can travel toward us. There might be other galaxies out there, other civilizations, other beings looking up at their own night skies and wondering if they're alone. And we'll never know. We're forever separated by the expanding fabric of space itself. But that's okay. Infinity doesn't need to be comprehended. It just needs to be acknowledged, accepted, allowed to be what it is. You don't need to understand everything. You don't need to know how big the universe is or whether it's infinite. You don't need to solve the mysteries or answer the questions. You can just rest in the not knowing, comfortable with uncertainty, at peace with the limits of human understanding. Some things are knowable, some things aren't, and both are okay. The stars you see tonight are the same stars your ancestors saw thousands of years ago. The patterns have shifted slightly due to the star's own motions through space, but not enough to be noticeable without precise measurements. Your great-great-great-grandparents 100 generations back looked up at essentially the same sky. They saw Orion's belt. They saw the Big Dipper. They saw the Milky Way stretching overhead. They wondered about the stars just as you do. They told stories, created myths, found meaning in the patterns. And 100 generations from now, your distant descendants, if you have any, will look up at the same sky. The stars will have moved a little, the constellations subtly deformed but still recognizable. The night sky is one of the few truly timeless things. Technology changes, civilizations rise and fall, languages evolve and disappear, but the stars remain, constant and patient, witnessing all of human history from their distant vantage points. There's comfort in that constancy. No matter what changes in your life, no matter what challenges you face, the stars will still be there, shining quietly, indifferent to human affairs. They've seen everything: wars and peace, triumph and tragedy, birth and death, repeated countless times across the generations. And through it all, they've just kept shining, steady and reliable. You can rely on them too. When everything feels uncertain, when life feels chaotic, you can look up and see that some things don't change, that there's still constancy and order in the universe. The universe is large enough to hold all of human experience, all of human emotion, and still have room left over for billions of years of stars burning and galaxies turning and space expanding into the infinite dark. Your problems are real. Your feelings are valid. Your experiences matter. And also, they're tiny, barely a ripple in the vast cosmic ocean. Both things can be true at once. Now, as we approach the end of our journey tonight, let yourself settle even deeper into rest. Feel the weight of your body, supported and safe. Feel the quiet rhythm of your breath, in and out, steady and calm. The night sky will still be there tomorrow. The stars will continue their slow dance. The universe will keep unfolding, moment by moment, breath by breath, and you will be part of it, as you've always been, as you always will be, connected to everything, made of stardust, held by gravity, breathing air that's been breathed by countless others before you. You are not alone, even in the darkness. You are part of something vast and ancient and ongoing. Let that knowledge comfort you as you drift toward sleep. Let it wrap around you like a blanket, warm and gentle and reassuring. You are exactly where you need to be. You are exactly who you need to be. And rest is waiting for you, patient and kind, ready to receive you whenever you're ready to let go. The stars are watching. The universe is holding you. And sleep is near now, soft and welcoming. Let your thoughts drift like leaves on a quiet stream. Let your worries dissolve like mist in the morning sun. Let your body sink deeper into comfort, muscle by muscle, breath by breath. There's nothing you need to do, nowhere you need to go, nothing you need to solve or fix or figure out. Just rest, just breathe, just be. The night sky has been here for billions of years, and it will be here for billions more. It's patient, it's eternal. It's a reminder that time is vast and forgiving, that everything is temporary, that rest always comes eventually. And now, dear friend, it's time to let the day fall away completely. Time to surrender to the gentle pull of sleep, to allow yourself to drift into dreams, into darkness, into the deep and healing rest that your body and mind need. Thank you for being here tonight. Thank you for taking this journey through the quiet mysteries of the night sky. May you sleep deeply and peacefully. May your dreams be gentle. May you wake refreshed and renewed, ready for whatever tomorrow brings. The stars will still be there, shining their ancient light, waiting to welcome you back whenever you're ready to look up again. For now, close your eyes, breathe deeply, and let yourself fall softly into sleep. Good night, dear friend. Rest well. The universe holds you in its vast and gentle embrace.